Hi, I'm Miss Hall, and this is Lesson 91, Populations and Samples, Parameter and Statistic. We'll begin with populations and samples. A population is the collection of all data, such as responses, measurements, or counts that you want information about. Population is a collection of all data. That's important. A sample is a subset of a population. So if we were to draw a diagram, we could have the population as that entire area, and then a subset within the population, we're going to pull a sample, which is a subset of the population. A census consists of data from an entire population, but unless a population is small, it is usually impractical to obtain all the population data. In most studies, information must be obtained from a random sample. You will learn more about random sampling and data collection in the next section. It is important for a sample to be representative of a population so that sample data can be used to draw conclusions about the population. When the sample is not representative of the population, the conclusions may not be valid. Drawing conclusions about populations is an important use of statistics. Recall that statistics is the science of collecting, organizing, and interpreting data. Example 1, distinguishing between populations and samples. Identify the population and its sample. Describe the sample. A, in the United States, a survey of 2,184 adults ages 18 and over found that 1,328 of them own at least one pet. Okay, so the population is going to contain the word all. Population is the responses of all adults ages 18 and over in the United States. The sample, or the subset, is the responses of 2,184 adults in the survey. For B, to estimate the gasoline mileage of new cars sold in the United States, a consumer advocacy group tests 845 new cars and finds they have an average of 25.1 miles per gallon. Okay, the population is going to contain the word all. The population is the gasoline mileage of all new cars sold in the United States. The sample is the gasoline mileage of 845 new cars. Okay, so you should notice here that, as I'm stressing, population contains all. And then I've started my population and sample the same way. Responses of all, responses of, and then the sample size, 2,184. Gasoline mileage of all, and the gasoline mileage of, and then the sample size. Now on to parameters and statistics. A numerical description of a population characteristic is a parameter. A numerical description of a sample characteristic is called a statistic. Because some populations are too large to measure, a statistic such as a sample mean is used to estimate the parameters such as the population mean. It is important that you are able to distinguish between a parameter and a statistic. Right, so a parameter deals with a description of a population, a description of all, and a statistic deals with a characteristic of a sample, a numerical description of a sample or a subset. So this will be not all. Not all. For all students taking the SAT in a recent year, the mean mathematical score was 514. Is the mean score a parameter or a statistic? Explain your reasoning. I see the word all. This is a parameter of all students taking the SATs. It is a parameter because it is based on all students who took the exam. For B, a survey of 1,060 women ages 20 to 29 in the United States found that the standard deviation of their heights is about 2.6 inches. Is the standard deviation of the heights a parameter or a statistic? Explain your reasoning. Well, it does not contain the word all. This is a survey of a sample of the population. So this is a statistic. Because it is based on a sample group. And I put in parentheses, not all. It's not based on all women. Okay, so that was parameter versus statistic.